Hey, hello there. How's it going? This tutorial will focus on creating an intermediate level foliage scatter tool using PCG in Unreal Engine 5. To put it simply, a foliage scatter tool is a tool that helps simplify and speed up the process of generating and placing foliage on a surface within Unreal Engine. A little bit about my background. My name is Siddhant, and I'm an Unreal Engine game developer and trainer. I've been working with the engine for over 8 years now, and I've worked on projects that range from games to interactive experiences, mobile experiences, and much more. And I really enjoy making games and interactive experiences inside Unreal Engine. Now, let's quickly go over what you, the learner, will learn by the end of the session. Number one, you will have developed a PCG graph and volume to scatter foliage assets on a landscape. You will learn techniques to develop a slightly more complex PCG graph to scatter foliage on a landscape, and you can then use these techniques as a foundation for building your own PCG tools to assist you in the development of your own projects. Second, you will learn and employ a technique for grouping points. We'll look at how to use nodes to create distinct groups of points that we can then use for various purposes. Number three, we'll employ a technique for selectively spawning elements on certain points. So we'll look at a technique for fine-tuning where objects are spawned. Number four, we'll employ node debugging to better help with visualization of scattered points. And this will basically just help us to understand how our points are scattered in the subgraph. And lastly, we'll also learn how to use subgraphs, in that you will be able to reuse PCG graphs as subgraphs and learn how to separate point generation from asset placement. Certain prerequisites will be necessary for better understanding the contents of this tutorial. Number one, familiarity with the PCG plugin. You should be familiar with the basics of working with PCG. These include topics like, for example, how to enable the PCG plugin, what are samplers and why are they utilized, what are points and what is point density. So essentially core topics and mechanics that relate to PCG. Number two, ability to create simple PCG graphs and volumes. So you should also be able to create simple PCG graphs and set up those volumes in levels. This includes familiarity with common PCG nodes, how to combine nodes together or link them together to generate outputs, and how to modify parameters on nodes to modify outputs that are seen in the level. Having a basic understanding of these fundamentals will help with understanding this tutorial much better. However, with that being said, I will still be explaining the reasoning behind actions that I take while developing the PCG graphs. Alright, with that out of the way now, let's understand how we'll build the scatter tool. I've mentioned a fairly high-level approach that I'll be following for creating the foliage scatter tool during the course of this tutorial. We'll start by enabling the PCG plugin. Then, we'll first begin by creating the subgraph. The idea behind using a subgraph is to create a simple PCG library of sorts that will only handle point generation and scatter for us. Note that I'm not talking about scattering the foliage directly right now with the subgraph. The subgraph will only generate groups of points for us, and the main graph will contain the meshes to spawn. The advantage of this approach is that we can then include and reuse the subgraph to spawn any kind of object with varying object densities rather than just foliage. And we can reuse this graph in as many different container graphs as we want. Say tomorrow you want to reuse the graph to maybe spawn a different kind of tree and grass with different densities. Or maybe you need the point generation for spawning elements for something completely unrelated to foliage. The point generation logic is already created for us, and all we need to do is add it to any container graph, which will then execute it. After this, we'll then work on the main container graph. This will be the main graph that runs the scatter generation for us. This will contain additional point generation logic and also will be responsible for spawning the foliage for us. This will also contain the subgraph and will execute it. We finally combine the results from the main graph and the subgraph to get the final output. Now, talking about outputs, this is what the final output that we will obtain by the end of the session will look like. Alright, now talking about outputs, this is what the final output will look like. So you notice we have the trees, we have the distinct regions of brown dry grass, and we have the green grass all around it. Now let me zoom in a little bit to one of these sections. Now you'll notice that there are two very distinct sections in this foliage setup. The first one is the patch of dry brown grass, which includes flowers and also a tree at its center. And the second section is the green grass that you'll find scattered much along the rest of the area. So the subgraph will be responsible for generating the points and only the points for the clumping of the tree, the dry brown grass, and the flowers. Alright? And the main container graph, on the other hand, will be responsible for spawning everything else, including the green grass, the assets such as the tree, the flowers, and the dry brown grass that you see under here. Next, let me show you what the results of each graph will look like. The first is the subgraph and the points generated from it. Now, this is the graph that is responsible for generating the point group for us. But you also notice we are not really spawning the foliage assets just yet. It's only the points. This is where the debug visualizations come in very handy, since we can directly view how the result will be without needing to spawn any objects while developing the graph. Next, we have the point groups with assets spawned. This is the result of running both the PCG subgraph and the main graph. The subgraph generates the points, and the main graph is responsible for spawning the assets at those points. This is a close-up of the clump. There will be a certain amount of randomization for the placement of flowers and dry grass around the tree. So usually the pattern of object placement will vary from tree to tree in the generated foliage system. This is what the green grass will look like without the subgraph present inside. And this particular output will be generated from the main graph exclusively. This will be the result of bringing both the subgraph and the main graph together as the final output. Alright, with that explanation completed, let's focus on constructing our PCG graphs now. Before we do that, however, let's talk about how we'll get started. I will be using Unreal Engine 5.5 and I have created a new project here already. I will also be using the Meadow Environment Setback, which contains all the foliage assets that I require, namely the trees, the flowers, the dry grass, and the grass. In case you do not have access to this pack, then feel free to use any other foliage pack that contains grass and trees. You should be able to achieve similar results from the Foliage Scatter tool. I will also need to create a new open world level since I need to access the landscape. And I want to have access to a ready-made landscape for that, so I will come down to File, select New Level, and I will click on Open World Level. Now, with that done, I will also go ahead and save it. So I am going to right-click in the content browser, and I will create a new folder called as Maps. And I'll save this new level inside here. I'm going to press Ctrl S, and I will save this map as m_test. All right. Now, after this, the next thing I need to do is I will activate the PCG plugin. So I'm going to come down to Edit, select Plugins, and in here I will search for PCG. And I will simply select Procedural Content Generation Framework, the first plugin that you see here. It's going to ask me whether I want to activate it. Since this is a beta plugin, I will just select yes, and then I will restart the engine. And with this, we are now ready to get started. All right, we are now ready to start building our PCG graphs. I'm going to open up the test map, and I'm going to find a location somewhere around here. This should be good enough. And I'll now create a new PCG folder. So I'll right click in the content browser, create a new folder and call it as PCG. Inside here, I will add a new PCG graph. So I'm going to right click, select PCG, and I'll click on PCG graph right here. And I'll name this as PCG underscore points. This will be the subgraph. Now, before we actually start creating the graph, let's look at some of the technical details of our setup. So this is the output that we'll be aiming for with the subgraph. In here, you'll specifically notice that there are two categories of volumes. You have the larger volumes that are scattered, and you have smaller volumes contained within them. And each of these end up forming up one group or one cluster that will hold trees, dry grass, and flowers. Now, to achieve this, we will require two different samplers with different parameters. Okay, let's open up the PCG points graph now and let's get started. First things first, I need access to the landscape data. So I will right click, search for get landscape data. After this now, I will need two samplers, two surface samplers. The first one will be for the larger volumes and the second one will be for the smaller volumes. And then we'll intersect the two of them to get common points between them. So I'll start off with the smaller surface sampler, which we'll be using for the grass and the flowers and effectively the grouping around the main tree. So I'm going to drag a wire out from get landscape data and I'm going to search for surface sampler. Now, with that done, I will change some parameters on this. But before that, before I change those parameters, I need to also be able to visualize the node and what it's doing. So I will just drag and drop my PCG points volume into the level and I will enable debug on the surface sampler. To enable debug, I will right click and simply select debug. The shortcut key for this is the D key on the keyboard. So now you'll notice that we have all of these points that are scattered within the volume. Now, this is way too less for creating groups or creating clusters of grass and flowers. So what I'm going to do is I'm going to increase the number of points that you see here. Now for this, I will need to change the points per meter square per squared meter and the point extents as well. So I'll set this to 10 and point extents, I'll set that to 10, 10, and 10. There we go. Now we have a properly filled volume with really small points. And at each of these points, you could have either grass or you could have flowers. But now we also need to be able to cluster them. So we don't want the entire volume to be filled with these. So for this now, we will need to create a second sampler, which I will do right here. So I'm going to drag a wire out and I'm going to search for surface sampler. Okay. Now inside here, this sampler will need to be much larger. So I will change the parameters on this to read as 10, and I'll keep 100, 100, and 10 for the point extents. And let me debug this node as well. Now, an interesting aspect of PCG is that you can debug multiple nodes simultaneously. So I can visualize the surface sampler for the grass, and also for the volumes that will group or that will create the clusters simultaneously. So all I need to do here is just right click on the second surface sampler and simply select debug. And now you'll notice that we have these volumes showing up over here. Now the idea is that we will take each of these points, and wherever we have these smaller points overlapping with the larger ones, we will simply cluster them and consider that as one group or one cluster. Now, definitely I need these boxes to be larger and also to have some amount of rotation on them as well. So let's focus on the larger boxes now. I'm going to disable the surface sampler debugging on the smaller points so that we're just left with these larger ones. Now, we want to apply a random rotation to these larger boxes. To achieve that, I will use what is called as the transform points node. So on the second surface sampler, I'm going to drag a wire out and I'm going to search for transform points. And in here now, I'll just give these some random rotation. So I'll go with rotation minimum at -90 and rotation maximum at +90 along the z-axis. And now if I debug this node, and if I disable debugging on the surface sampler, you'll see that we have some proper randomized rotations for our points or for our volumes. Now the next thing is we also need to increase the size or the scale of these volumes. Now, in order to achieve this, I do not want to modify the scale of the transform points, because that will also modify the scale for the asset that we spawn later. So what we want to do is we want to modify the bounds without affecting the scale of the object itself that will be spawned potentially later. To achieve this, there is a node called as bounds modifier, which lets us do just that. It allows me to scale the bounds of the volume without actually modifying the scale of the object that will be spawned at that point. I'm going to disable the debugging on the transform points node, and I'll activate it on the bounds modifier. And currently you won't really see any difference here, but if I change the bounds min and bounds max, you'll start seeing some differences. So I'll set this to 1.5, 1.5, and 1.5 to 2. So we'll just get some randomized variations in those sizes. From here now, you'll notice that a lot of these volumes are actually overlapping with each other. Now that's okay if you want to set it up like that, but in my case, I want to avoid overlaps. So I'm going to use another node called as self pruning, which will remove those overlaps for us, or it'll eliminate the overlaps. So I'm just going to search for self pruning and I'll connect it here. Now I will debug this as well. And there we go. We now have a properly spaced out series of volumes that are not overlapping with each other. Next, we now need to intersect the larger points with the smaller points. So if I activate the debug on the smaller surface sampler, you'll see we have this pattern now. So let's look at how we can achieve that. Now, there's a very helpful node that will assist us with clustering these points. It's called the intersect node. So I'm going to right click and I'm going to search for intersection. I'm going to go with the intersection node. And the primary source in here is going to be my first surface sampler. I'm just going to drag this into the primary source. And the secondary source is going to be the surface sampler and all associated nodes for the larger volumes that are under here. Let me connect these together, and let me right click on the intersection node and debug this now. All right. And also let me remove the debug on self pruning and also on the surface sampler for the smaller points. All right. And there we go. So now you'll notice we have these clusters or groups set up quite nicely. Now, just to confirm that everything is looking good, what I'm going to do is I will keep the intersection debug active, and I will also activate debugging on the self-pruning node. All right. Now you'll notice one problem here. We have some cubes that are outside the bounds of the larger volumes. Now we want the larger volumes to encompass the entire cluster. So the way to fix that is to really just come into the surface sampler for the larger volumes and set the point steepness from 0.5 to 1. And that now ensures that the larger volumes properly encompass the smaller points. So now we have our groupings set up properly. Next, we'll check what these clusters look like without the larger volumes now. So for that, I will disable debugging on the self-pruning node and just keep it activated on the intersection node. And there we go. We have our clusters properly set up. I also want to change the density of each of these points, randomize it between a lower range. To achieve that, I will head over to the intersection node, and from the out pin, I will use a density noise node. This will just remap, or rather, this will just modify the densities between a new limit that we choose. So I'm going to change the noise minimum to 0.4, disable debugging on intersection, and just enable it on the attribute noise. And you'll see we have changed how the densities appear for the clusters. Now, this will be helpful for us later on when we are spawning or when we are generating and placing assets at those points. With this, our graph is nearly done. Our subgraph is nearly done. Next thing that's left is to really output these parameters, these values, so that my container graph or my main graph can actually utilize these results. To do that, I am going to use the output node. This is a node that comes by default with each new PCG graph that you create. And I'll just drag and drop it over here. Now there's two things I will require here. One is the output for the grass point. So that's this output that I'll need to pass in here. And also the output from the self-pruning node, since that will act as the center of our cluster. Now to expose these outputs as pins, I will select the output pin, the output node, sorry, come over to the details panel, and in here under pins, under index 0, I'll change the label from out to grass points. Also, I will change the pin status from advanced to normal. And you'll see now that we have a new pin that appears here. Now, when you say allowed types, when you set allowed types to any, this means that any kind of data can be passed to it. Or you could also constrain that to any more particular type of data by changing the type from the drop-down list over here. I'm going to leave this at any for now. And I'm just going to pass the output of attribute noise to the output pin on cross points. Lastly, we need one more output pin here. So I'm going to select the output pin once again, come back to the pins drop down or the pins array, select the plus button and repeat the same process again. This time, however, this is just going to be my center point. And the self pruning's output, I will pass it inside here. I'll also add a reroute node over here just so that it is better organized. And we are now done with this particular graph. That's it. Now let me save this. And this is what a final graph looks like. Now that we are done building this point structure via the subgraph, let's move ahead and combine this with the main graph to produce the following outputs. Now, in order to achieve this, we will need to create a second graph, which will be our main graph. Let me come in here and right click. I'm back in my PCG folder and I'm going to create a new graph, a new PCG graph that is, and I'll name this as PCG underscore main. I'll double click on this and now we'll start off by calling the subgraph that we created. To do that, there is a node called as subgraph node. I will right click, search for subgraph, and I will use this. Now it's saying missing subgraph because we need to set up which graph this will call for us. So I'm going to select the subgraph and I will come over to the details panel. Over here, there is the graph parameter. Select the drop down and simply select PCG points from that. And now you'll notice that you get the pins that we set up on the output pin in that graph available right here. And this is how you can access the results from that graph inside the main graph. Now, we still aren't done with spawning items. What we've achieved till now is only spawning points that are present in the world. Now, since we have a subgraph for that, we can call this in wherever we want and we can use it to spawn any kind of objects that we want. Now, this is the entire point of having a separation between how the points are generated and how the assets are spawned. Now, in here, we are still going to be focusing on the cluster that we worked on. We will be effectively just building out this thing now, this particular output. So next thing, let's come to the grass points pin. And what I want to do is I just want to see what this looks like. So I'm going to drag a wire out from here and I'm going to simply search for static mesh spawner. But remember that we only placed the subgraph in the level. We haven't placed the main one yet. So this is no longer required. I will delete it and I will now drag and drop the main graph in here. So you'll see we have our points generated as always. But now when I actually add some meshes inside the static mesh spawner, they will also show up here. So let me come down over to mesh entries. And this is just going to be concerned with spawning the dry grass and the flowers. So I'm going to simply add a static mesh here for the dry grass. In this case, it's called the dead grass. So I'll go with, let's say, dead grass 03. Or probably I'll go with dead grass 01. All right. Yeah, that's the one that I want. Now, if I head over here, you'll see that our grass is spawning properly, and we have the grass spawned right in the clusters where we wanted them. There's also this issue with the debug points now showing up. I want to disable them, so I will head back to my subgraph and I'll just disable the debug on this node. That's it. So now you'll see we have the grass over here. Now the grass is probably way too thick, so I need to reduce the amount of grass that is spawning. Now I can do that very easily using the density filter node. And this is exactly why we had set up a density value here, or this density noise node here. The noise minimum is 0.4 and the noise maximum is 1, which means that if we filter using the density filter node, we can sort of set a range between which grass can spawn. So for example, in this scenario, if I drag a wire out from here and I search for density filter, and let me just break this link. I'm going to break a link by holding down the left Alt button and clicking with the left mouse button. And then I'll connect this output of the density filter inside the static mesh spawner. Now, let me select the density filter and let me change the lower bound to be zero 0.4 and the upper bound to be, let's say, 0.6. Now, if I come back here, this looks like it's worked a little bit. Let me reduce it even further. So 0.4 to 0.45, for example, and you'll notice that we have a very little amount of grass now showing up. So I could continue modifying these values till I find something that I'm satisfied with. So anywhere between 0.4 and 0.5 is okay for me. And that looks quite all right. I can do the same thing with the flowers now. So for the flowers, I'm going to drag a wire out from this filter and I'm going to add another density filter. Now, this is the first density filter for the grass is between 0.4 and 0.5. For the flowers, I will set it to 0.5 to 0.7. I could go higher, but I feel this will look better. And I'll add another static mesh spawner, which will contain the flowers for me. So I will go with, I guess Poppy02 should be fine. There we go. So you'll see we have these flowers now present here. Okay. To complete this, the last thing left is to spawn the tree as well. So I'm going to drag a wire out from the center point and I'm going to search for static mesh spawner. And I will simply add my tree inside here. So under mesh entries, I'll select tree and add it in here. So let's see, there's a bunch of them. I'll go with popular tree 06. There we go. We now have these clusters properly set up. The last output left to create is the main graph output, which is this green grass that is not overlapping with the clusters that we created previously. We are nearly at the end now. All that remains is to spawn the green grass in regions where clusters are not present. To achieve this now, let's head back to our main PCG graph. And in here, I'll start by adding a new landscape node, a landscape data node. And as we did before, I will need to add another sampler, another surface sampler. This will generate points across the entire volume. And I will set up the points per square meter to about 20 and point extents to maybe 10. Let's see what we get with this. So I'm going to debug. So we have a fairly dense field of points. And you'll see that they are also overlapping with the clusters. We don't want that. So we'll get to that fixes next. Now from here, I also need to access the center point of the cluster in order for removing any points that are around the clusters. I'm going to get the center point, and I'm just going to use the bounds modifier node to apply a region inside which we do not want any points. So I'm going to select this. I'm going to set the bounds modifier to have a width of about 2.5, a fixed 2.5 in both the minimum and maximum. And now I will use the difference node to remove points that are overlapping with our cluster. Now, just to show you what the bounds modifier looks like, I can right click and debug this as well. Now, this is probably way too large. So I think bring it down a little bit should be fine. So I think somewhere around 2, let's see if that will work well. I think that should be okay. And all I need to do now is come in here, right click, search for difference. And I'm going to connect the out pin of the service sampler into the source of the difference node and the bounds modifier to the differences node. The output of the bounds modifier to the differences node. I'm going to disable debug on both of them. And now I'm going to head back over here. Now you'll notice that we don't really have any points showing up here right now. That's all right. I'm just going to right click on the difference node, debug that. Now let's see what we have. So we have some areas that are still having points on the clusters. So like for example, this area here and this area. Now in order to fix this, what we can do is we can just change the density function from minimum to binary. And this will remove those extra points, those overlapping points that remain on our clusters. And from here on out now, we can simply go ahead and add a static mesh spawner. Select that. I'm going to come down to the mesh entries and I'll just add some green grass in here. So I want to look for grass meadow. I believe meadow 03 would be fine. All right. I'm also going to go ahead and remove the debug on the difference node. And there we go. We could also just add a density node, density filter node between the difference node and the static mesh spawner. And this will just reduce the amount of grass that we see. I'll connect it over here. Oh, sorry. Actually, I'll connect it right here. And I will break this link since we don't need it anymore by deleting it. And now the density filter, I'll just change it, set it to something like point, let's say 3 to 1.0. And that's it. We now have our volume, and the green grass does not overlap with the clusters that we've added. And this is what our graph looks like. All right, with this, we have effectively finished making our PCG graphs. However, some additional adjustments can be made to improve the generation of the foliage. Now, to illustrate some of the problems that we have, I have taken the liberty of placing a new volume at this location. Now, you'll notice two things immediately. Firstly, the density of the green grass, while it's not overlapping with the clusters that we created, it is still fairly sparse. So that's the first thing I want to change here. I want to increase the density of the green grass while still maintaining the sort of distribution that we have such that it's not overlapping with any of the clusters. And secondly, you'll notice that some of these trees are aligned to the terrain surface normal, such as this one, for example, which is something that we might want to avoid or we might want to correct. So I'll show you how to fix both of these. Let's come to the first one, which is the grass sparseness issue. First things first, let me come back to the main PCG graph here. And this is a pretty simple fix. I'm going to select the bounds modifier, which is connected to the center point. And the current minimum and maximum bounds are set to 2.0 for both minimum and maximum. I will set this to 1.4. And now, if I come here, you should see that the amount of grass that we have has increased. I could further decrease the minimum and maximum bounds, set these to 1.2, 1.2, 1.2, and repeat the same down here. And you'll see that it's already starting to have a pretty good effect over here. All right. You can also change the grass if you want more dense grass. So another option is to change the mesh itself. So right now we are using grass meadow 03, which is pretty small like this. I could use 03 with another grass mesh, which is mesh 05, grass mesh meadow 05, and that should improve the look a little bit more. All right. You could also go ahead and change the density filter. Currently it's 0.3 to 0.8. You could set it all the way to 0.9 or even 1 to sort of increase the density of the foliage of the grass on the ground. And so there you have it. We fixed the first problem. The second problem pertains to the alignment of the tree. In certain scenarios, you may not want the tree to be aligned to the surface normal as you see over here or over here. Now to fix this, I will open up the subgraph, and at this point where we have the self-pruning node, again, this whole part here, this entire chain is responsible for aligning and placing the trees. So what I will need to do here is I will need to use a node which is called as the projection node. So I'll right click, search for projection, and I will connect this to the self pruning node. And the output node, I will connect it to this existing connection. Besides this, I will also need another important node, which is the landscape node. Right click, get landscape data, and connect this output to the projection target. Now, what you want to do here, you want to select the get landscape data node, and in the details panel, make sure you select get height only. Now, when you check this, what this will do is it will only make sure that get landscape data returns only positions on the landscape rather than positions and surface normals as well. So this in turn will align the trees to the positive, the upward z-axis, the upward global z-axis. Because now we are no longer getting surface normal data, we are only getting the position. And so this is what the final subgraph looks like. Let me zoom in. So we have the usual landscape data and surface samplers that we had created earlier on. We have the transfer points and the bounds modifier. All of that remains as it is. However, we just end up connecting this projection node and get landscape data to the self-pruning node. And we pass that as the output to the center point. That's pretty much it. And with this final change, the output now looks like so. And thus, we finish with our session for today. We've finished creating a foliage scatter tool using PCG or Procedural Content Generation in Unreal Engine. And we've employed different techniques to generate clusters, to filter where foliage can grow and where it should not grow. And also we've looked at how we can address certain problems such as increase the density of foliage in certain areas and align trees in case we do not want them to be aligned to the surface normal. We also looked at how to create a subgraph, how to expose pins from that subgraph to utilize in other graphs. And we've also, and the process of creating subgraphs essentially lets you, or it allows you to create libraries so that you can reuse different graphs in different scenarios. So I hope that the techniques that we covered in today's tutorial will help you in designing your own projects, in improving the design of your own projects further. And I really can't wait to see what you guys create using the techniques we covered in today's tutorial. Thank you everyone for watching. Have a great day, and we'll see you next time.